The test is going to be online, you said?
No. We are assuming it's going to be in class on Wednesday, next Wednesday, right? Unless we get more information. So watch your email, look at Canvas, make sure, right? Make sure that you understand whether you're coming in that day, but do not assume we are not taking the test, because we will take the test whether it be Wednesday. If it does happen, it'll get pushed back a little bit.
Okay.
All right?
I have a question with that.
Yeah.
Say we get a week off, would that be our spring break?
No. If it happens, it's probably not going to be a week off.
Okay.
Okay?
I remember the spring
It's probably,
semester with the snow.
it's going to be, we're going
Remember the
online for
snow?
the rest
A
of the
week and a
semester.
half.
They didn't take our spring break either. We got smoke time and our break.
All right, so
We got smoke time and a different kind of smoke time.
let's focus. We got some things to do. We got some things to talk about. So full focus on the math, not the virus. All right. So actually, I think I'm gonna kind of skip this one. I'll let you work on that one. Right? Come back next time. Let me know how it went. Yell at me if you didn't like it. Kind of thing. Let's move on to that at least one scenario that Jasmine and I were talking about at break. At least one probability. So sometimes when you're given this kind of condition, and it does actually happen quite a bit in life, and we'll have some really good examples there. Not this one totally, but so there's something to think about. Sometimes it's easier to calculate the complement set so than at least one. So because technically at least one means one or more. So I could have 1, 2, 3, 4, 5. Where do I stop? Sometimes I don't know where to stop. Right? And what position does that thing happen? Is it the first one? Is it the second one? There's so many or statements that get involved with this at least one that sometimes it's almost impossible to actually calculate that statement unless I use the complement set. So the complement set for at least one, right? We've been talking about it, right? Complement set, just to kind of recap, right? Complement set is the complete opposite space, right? So if there's a 30% chance to rain, that means there's a what percent not to rain? 70%, right? So it's that idea of, right, I got 1 minus that 0.3 or 100% minus that 30% to get that 0.7, right? Or something like that, right? So we can use, we talked about this formula in the past, we can use this complement formula to be able to say, oh, I figured out why we have 2 here. Last night I couldn't figure out why we had 2 there. So we can take 1 minus the probability of none, which is the complement space of at least one. The complement of, I can't fit it in there, at least one. It's the complete opposite space. Right? If I say that I have at least one, then the opposite space is none of a curve. And will probably make more sense when we get into these problems, why that is so.
What word is that? Does it say?
Like you can't read my writing, is that what you're saying?
Well, no, I can read it. I just,
That's the complement of at least one.
so, complement of at least one what? I'm done. So.
Yeah, so let's go to the example so that we can make more sense of it. Because I need something to be able to, right, make it more concrete for you.
Right, okay.
All right. So let's talk about this example one, kind of just a silly example in a sense, but we do have real world examples in this case. I believe this is where you have the idea of a virus example in your homework. So, right, nice depressing little problem for this topic that we're talking about right now. Right, so there is one on there. I have used it in the past. I didn't want to bring it into today's topic. It's particular, so you can look online. All right, so, and they do this kind of stuff. So, all right, so on a typical day, the probability that my wallet has no dollar bills at all is 20%. What is the probability that on a randomly chosen day, I took my wallet and I find at least $1 bill? So those are the complement spaces of each other, right? If I had at least $1 bill in my pocket, right, that would include one, or maybe I have $2 bills, $3 or 4 or 5 or infinite, and then I would take you all out to lunch because I'm really rich. Right. So right, you can go really far. I don't know where to stop, right? I don't know where to stop for my dollar bills kind of scenario. So I have many statements, and this statement of finding the probability of at least one is an or statement. I could calculate the probability of having $1 bill in my $1 bill in my pocket, or I could calculate the probability of $2 bills, or $3, or $4, or 5, or 6, or 7, or 8, or 9 kind of thing. There's too many probabilities to actually calculate kind of thing, to be able to do the addition rule that we've talked about. So taking a step back and thinking about, well, if I could calculate the probability of at least, for the probability of none, then I can use that complement idea to be able to figure it out. So in this case, we're going the opposite way of what we typically do. Took my wallet to find at least one. I'm using this idea that it's 20% of the time I have no dollar bills in my pocket, whereas, so probability of none equals 1, I'm sorry, so 1 minus, I wrote that wrong. The probability of at least $1, at least $1 equals 1 minus the probability of none. No dollars, which is 20% or 0.2. 1 minus 0.2, as we said, was 80%, or 0.8. You can use either case or the other. You did have it. Didn't you answer a point? I thought you answered that.
I mean, I had the 80%, but I was thinking of an event prime. You know how the event prime
This is the event
opposite.
prime. This is exactly that. This is the prime. This is the prime of that.
Okay.
So that's why I use that well, but there should be like a little prime right there.
Yeah.
Instead of saying complement, it's just tough to kind of use that notation. So.
Because my mind had 80% as the prime, but it's actually the none.
But it doesn't matter, because that is the prime of that one, and this one is the prime of that one. So vice versa. They go back and forth, right?
Okay.
No rain or rain are the complement sets of each other.
Oh.
Yeah? Yeah. No, that was a good statement, right? So they are the complements of each other, and we can use that formula in vice versa, and we will. We use it 2 times in some cases to do this. And this is kind of the one statement that kind of follows us out throughout the semester. This idea of subtracting 1 or 1 minus the complement space. It follows us throughout the semester. Okay? So it's an important concept. Oh, we need to stop recording.